This session is the Exam 1 review, presented by Yvette Chuque, Ruben Carrizales, and Albert Isasi. This session will be recorded. This event will provide the 100 passport points. It will post in the chat at the end of the session. So now, in this time, please meet your mix for the best sound experience. Without further ado, here is Yvette Chuque and Mr. Carrizales.
Hello, everyone. Happy Friday. Hope everyone is having an awesome Friday. So, today we're going to talk about Exam 1 review. And some of you are taking the exam this week, and some of you might be taking it next week. But hopefully, the review will help you to get prepared. If you're in 1324, Mr. Isasi is in another room, so you can just click the link and it'll take you to his room. And so we'll get started. So the first thing that we want to look at is finding the distance and the midpoint between 2 points. And so here they give us the point 8,4 and 8, -6. So the important thing to remember is going to be the formula. So the formula for the distance is x2 minus x1 squared, y2 minus y1 squared. And if you notice, I labeled my points up here as x1, y1, x2, y2, or you could have reversed the order and said that this is x2, y2, and x1, y1. So if we plug in these numbers, x2 is 8, x1 is 8, so we have 8 minus 8 squared, and then y2 is -6, y1 is 4. So 8 minus 8 is 0, -6 minus 4 is -10. So 0 squared is 0 and -10 squared is 100. So you want to make sure that we simplify. So the square root of 100 is going to be 10. So the distance between these 2 points is 10. Now for the midpoint, we have a different formula, x1 plus x2 divided by 2 and y2 plus y1 divided by 2. So again, we can plug in our points. So x1 is 8, x2 is 8, y2 is -6, and y1 is 4. So 8 plus 8 is 16 divided by 2, and -6 plus 4 is -2 divided by 2. Simplify, so we get 8 and -1. So that is the distance and the midpoint. So these are both problems from section 1.1. Now we're going to look at circles. So write the standard form of the equation of a circle with the given characteristics. And so they give us the center of -4, 2, and a radius of 2. So one of the things that you want to remember is the standard form of a circle, which is x minus h squared plus y minus k squared equals to r squared. So in this standard form of a circle, the h and the k represent your center. And so for my center here, I'm just going to label it as h and k. And then r is going to be your radius. So in our example, they tell us that the radius is 2. So if we plug in these numbers, we get x minus h, which we saw is -4, and y minus k, k is 2, and then our radius is 2, so we're going to square radius, and then you want to simplify. So negative negative would become positive, so we end up with x plus 4 squared, plus y minus 2 squared, and 2 squared is 4. So that is writing the standard form of the equation given the center and the radius. Let's try a different one. So now it's asking us to find the center and the radius. So I always like to write down the standard form. That way I can have it in front of me. And so here, if I go ahead and write the equation below my standard form and compare it, we can see that this is a minus sign. I have a minus sign. So h is going to be 1. But in this case, I have a minus sign and an addition. So in order for me, I cannot say that k is 2 since we don't have the same sign here. So this plus sign we can change as a negative or a minus sign with a negative 2, because negative negative would be positive. And so now if I compare, my h is 1 and my k is going to be negative 2. And for our radius, we can set it up as r squared is equal to 25. Take the square root on both sides. And so our radius is going to be 5. So our center is 1, negative 2, and our radius 5. Now, one of the shortcuts you could look at is your center is just going to be the opposite sign of what you see in here. So if you have a minus 1, we end up with a 1. If you have a plus 2, we end up with a negative 2. And the reason we can do that is these steps right here that I just showed you previously. What if we need to sketch the circle? So if we need to sketch the circle, you're going to need to identify the center. So in our problem here, our center is going to be 1 and negative 2. And then the radius is going to be 5. So you take the square root of 25, which is going to be 5. So we plot, we can put our center here is 1, negative 2. The radius, that means that we're going to go up 5, to the left 5, to the right 5, and down 5 from our center. So if we connect our dots, then our circle is going to be these outer points here. Okay, so that is how you would graph a circle. At any time, if you have any questions, feel free to speak up or feel free to put it in the chat. Okay, so now let's look at something a little bit different, finding the intercepts and then test for symmetry. So here, to find the x-intercept, we let y equal 0 and solve for x. And so if y is 0, and then we're going to simplify here. So I'm going to subtract 1 on both sides. And then I'm going to divide by negative 4 on both sides. And so we end up with x is equal to 1/4. So this is my x-intercept. And to find the y-intercept, we let x equal 0. So we substitute 0 for x. Then we get negative 4 times 0 plus 1. Negative 4 times 0 is 0, plus 1 is going to be 1. So that's going to be our y-intercept. So if I were to plot these points and graph the line, then my line is going to look like this. And so we can see here that it has no symmetry. Okay. Now, if you didn't graph it and you still need to determine if it has symmetry, then we can also figure it out algebraically. So algebraically, to find out if it has symmetry, we have some tests. So for the x-axis, we're going to change that y to a negative y. So I'm going to write down my equation, and I'm going to replace y with a negative y. And then my goal is going to be to solve for y. So in order to solve for y here, I would divide by negative 1 on both sides. So I would end up with y equals negative 4x divided by negative 1 and 1 divided by negative 1. If we simplify, we end up with y equals 4x minus 1. So what you want to do is compare your answer, y equals 4x minus 1, with the original equation and see if they're the same. If they're the same, then that means that you have symmetry on the x-axis. In our example here, they're not the same, so there's no symmetry on the x-axis. So we need to check if there exists in the y-axis. So for the y-axis, we're going to switch the x to a negative x. And so here, I'm going to switch my y is equal to negative 4. Instead of positive x, I'm going to make it a negative. And then we're going to simplify. So negative negative is positive. Again, if you compare your answer here with the original, they are not the same. So that means that there's no symmetry on the y-axis. Now for the origin, we have to change the x and the y. So let's go ahead and do that. So instead of positive y, I'm going to write negative y. Instead of positive x, I'm going to write negative x. And then I'm going to simplify. So negative negative is positive, divide by a negative 1. So we get y is equal to negative 4x minus 1. So this equation is not the same as the original, therefore it has no origin symmetry. Okay, so again, you could either use the graph or you can try the test. So now let's determine if these equations are functions or not. So hopefully from the whole sections before, especially 1.6, you have an idea of what these functions or what families they belong to. So the first one, this is going to be, is this a circle, a parabola, a line? What type of equation is this? And so hopefully if you know what the graphs are going to look like, so in this case, I know that this is a line, and I know it's a line because the largest exponent of x is 1, and so that's going to make it a line. And so if I was to graph it, then really any line is going to be a function of x. And we can use the vertical line test and we can see that it's going to be a function. Okay, so any line is going to be a function. Now in this second one, we have, is this a line? Well, no, because the highest power of x is a 2. So hopefully by now you can see that you have, so for exam 1324, there's a link in the chat. You can click on it and it's going to take you to that other class. So here you have a power of 2. So the power of 2 tells us that this belongs to the quadratic family. And so if you were to graph this, it's going to be a parabola. And all parabolas are going to pass the vertical line test. Okay. So the third one, you want to ask yourself, what family does it belong to? And so here, the square root of x minus 4, that's going to be part of the square root family. And so the square root family they look like this. And so this is going to also pass the vertical line test. And then the last one, since the x and y are both squared, then that makes this a circle. And so the circle is going to fail the vertical line test. And so that's going to make it, no, it's not a function. And I have a couple more. So now the next two, we have y equals x cubed. So here the x cubed is going to be, so the x cubed is going to look something like this, and that's going to pass the vertical line test as well. So now, if we look at this equation, it doesn't look familiar. It doesn't look familiar to the equations that we've been working with. It doesn't look like any of the questions that were, any of the functions that were in 1.6. So this looks a little different. And so if you're not sure what the graph will look like here, then remember that we can solve for y. So in order to solve for y, I can take the square root on both sides. Since I'm taking the square root, then I have to consider the positive and the negative. So what does this mean? Well, if I do a test point, let's say x is 0, if I plug in 0 for x, then I get a 2. But if I plug in 0 for x in this second one, I'm going to end up with negative 2. So y, when x is 0, I'm getting 2 answers for x. Okay. So just if you're curious, since I'm getting 2 answers for y, this is not a function, and the graph looks like this. Okay, so it's going to fail the vertical line test. So when x is 0, it gave us 2 answers. That's why it's going to be not a function. Okay, so now let's look at some questions from 1.5 transformations. So here it says use the graph of f of x equals square root of x to write an equation for the function represented by each graph. So what happens here is we have something called transformations. And so our graphs can be transformed by shifting upward, downward, to the left, to the right. And so we're going to figure out what this equation is. So the first thing is to recognize that this graph belongs to the square root family. Okay. And so our parent function, I always like to draw the parent function just so that we have something to compare. So this is our parent function, and it looks like this. So we compare this graph with this one, we can see that the graph went down, okay? But we can also see that the graph went to the left. And so now we want to figure out what is going on. And so here, if we want to shift the graph to the left, then we're going to do that by having a +2 inside of the square root. And so that's going to cause your graph to shift over 2 units. So now we need it to go down. Okay, so in order for it to go down, we're going to subtract 8 units. So notice here it wants us to go all the way to -8. So if we put a -8 here, then the graph is going to shift down all the way to -8. And so our equation is going to be f of x is equal to the square root of x plus 2 minus 8. So anytime that you add or subtract on the outside of the square root, that makes your graph move up and down. If it's inside of the square root, that's going to make the graph move left and right. Okay, so let's try another one. So again, always start with your parent function so that you can compare. So just in words, what is happening with the graph on the left side if we compare to the one on the right? Well, we can see that the graph moved to the right and the graph also moved down, okay? But what else is happening? The graph looks a little different. So now we're going to have to worry about that as well. So it looks like it flipped, right? So let's take it one step at a time. So if I put a negative on the outside of my square root, then I'm going to have a reflection on the x-axis. So my graph is going to look like this. So is that the right type of flip, Mr. Carizales? Does that look the same as this type of flip? No. So that means that something else is happening as well. So let's continue. Okay. Now, if we flip on the y-axis, then now if you notice this purple one that I'm putting the mouse over, this kind of looks like this one here. Okay, so at least we have it facing in the right direction. And so now I just need to worry about shifting it left or right, up or down. So we need it to go to the right. So now if we want it to move to the right, we're going to subtract the -2. So inside of the square root, you're kind of doing the opposite. So we want it to go right, so we're subtracting 2. So now we're in the location where my mouse is pointing. And now I need it to go down. So in order to go down, we're going to subtract on the outside of the square root. And so we're going to subtract 5. And so now my function is down here. And that looks like the one that we had from the beginning. Okay, so your answer would be f of x equals negative square root of -x minus 2 minus 5. Yeah, these are so exciting, right? That's why it makes Friday such a happy Friday, because we have Friday Happy Math Hour. Okay, so let's look at another graphing problem. So this one is, I apologize, my picture is a little small here, but there's some buttons up here top of my mouse. You can always make your screen bigger, and it's not going to change anybody else's screen. So here we want to graph a piecewise function. So we have the square root of 16 plus x when x is less than 0, and 16 minus x when x is greater than or equal to 0. So I always like to break it up into pieces. So the first piece is that first equation, 16 plus x. So we also need to look at the conditions. It says to use this equation when x is less than 0. So numbers that are less than 0 are -1 and -2. but we also want to use 0 because there's numbers between 0 and -1. And so we want to capture all of them. So if I put 0 in for x, then I get 16 plus 0 is 16. The square root of 16 is 4. If I plug in -1 for x, then I get 16 plus -1, square root of 15. And then -2 would give me a square root of 14. If you want to plot these, you can use an approximation, the decimal here. But I went ahead and I plotted these 3 points. And I know it's a square root. And so I kind of have an idea what the shape should look like. But maybe with 3 points, it's a little hard to see. And so I'm going to add one more point. What if I have -16? So 16 plus -16 would give me a 0. And so now I'm at this point right here, right? And so if I was to connect the dots, then my graph is going to go from -16 and it's going to go all the way to I get to 0. But at 0, notice that you have a less than sign. So that means that at 0, we cannot use this point. And so I represent it with an open circle. Okay, so that's the first part of the equation. Now let's look at the second part of the equation. So same thing, but now the condition is greater than or equal to 0. So I'm going to use 0, 1, 2, and I'm also going to use 16. So when x is 0, then we get 4. When x is 1, we get square root of 15. When x is 2, we get square root of 14. And when x is 16, we get 0. So if I plot those points, then it's going to look something like this. And at x equals 0, notice I have a closed dot. But you want to put the graphs together. So I actually, on my paper, I like to graph them at the same time. But just to illustrate both of these, I wanted to do them separate here. But now we're going to put both pieces together. So if we did that, and here's my 2 pieces, and if I put them together in one graphing coordinated plane, then my graph is going to go like this, and then this side went this way. Now the open circle and the closed circle, they land on top of each other. And so the closed circle kind of takes over that open circle. Okay. And so then this would be my final answer. So this problem is from WebAssign. So you have actually, it's multiple choice. You can pick your graph, but I encourage you to graph them, and then that way you can see which one matches your choices there. All right. So now we're going to write the equations of lines. Okay, so in order to write an equation, you always need to have at least 2 things. You need to have a slope, and you need to have at least 1 point. Once you have those 2 things, then we can write the equation of a line. So for this one, they want us to consider if it's parallel or perpendicular. And so let me see which one I think we're gonna work on both. So the first thing you wanna do is you need to know the slope of this line here. So if we solve for y, we're gonna subtract 8x on both sides and then divide by -2. So we end up with y equals 4x minus 3/2. Once you get the slope from this line, there's nothing else that you need from this line, so we can ignore it. And so all you want to work with now is the 8, 1 and the slope of 4. So let's look at parallel first. So if 2 lines are parallel, that means that you're going to use the same slope. Okay, so we're going to use m equals 4 with the given point of 8, 1, and then we can use the point slope formula. So we have y minus y1 is equal to m times x minus x1. We're going to plot in our points. So we have y minus 1 is equal to 4x minus 8. We're going to distribute the 4. So 4 times x is 4x. 4 times -8 is -32. Add the 1 on both sides. And so my equation is y equals 4x minus 31. So if you were to graph this red line with this line over here, the lines would be parallel. Okay, the second part is perpendicular. So to find a perpendicular line, we're going to take our slope and you want to find the negative reciprocal of that. So if this is positive, you're going to work with negative, and then you flip the fraction. So remember, the 4 has a 1 under it. So if you flip it, we get 1/4. And then we plug in to the point slope again. So y minus 1 equals negative 1/4 x minus 8. Multiply the 1/4, and we get negative 1/4 x minus 8 times negative 1/4. Simplify. Negative 8 times negative 1/4 is positive 2. And then we're going to add the 1. And so our answer becomes y equals negative 1/4 x plus 3. Okay. Any questions? Again, you can always put them in the chat and we would help you with your question. So here we still want to write the linear function, but now it looks a little bit different, right? We don't have an equation. We don't have a point that is, like the other point where they give us the x and y right away. We have to kind of evaluate what is given. Well, when we see f of 1 is equal to 7, this 1 is representing x, and the whole function here is going to be your y value is 7. So we can get points out of this. So the points are going to be 1, 7, and 0, 8. So now we can find the slope by using the slope formula, y2 minus y1 divided by x2 minus x1. So we're going to have 8 minus 7 divided by 0 minus 1. And so our slope is negative 1. So now, is there anything special, Mr. Carizales, about either of these 2 points here that you can see?
I think the 0, 8 is an intercept, right?
Yeah, so when x is 0, that makes the number 8 your y-intercept. So remember, if you have y equals mx plus b, then we can just substitute our value in there. So we have y is equal to our slope, negative 1x, and our b here is going to be that 8. So we get y equals negative x plus 8. But let's say you totally forgot that this was your y-intercept, and your strategy is, I want to use the point slope here. Then you can still use this point slope formula, and you're still going to end up with this equation. This just that extra step. Okay. All right, so now we're going to evaluate functions. So find the function value if possible. So they give us our function and they want us to evaluate f of 1. So anywhere we see an x, we're going to replace that x with the 1. So we end up with f of 1 is equal to 3 times 1 minus 8. Simplify. So we get 3 minus 8 equals negative 5. And then the second one, we want to evaluate the function at x plus 4. So we're going to take this information, plug it in for all your x's, and simplify. So here I get 3 times x plus 4 minus 8. Distribute the 3. So 3x plus 12 minus 8. And then 12 minus 8 is 4. So my answer is 3x plus 4. And then we have one more here. G of 2 means that we're going to take the 2 and plug it in for all the t's here. Okay. So we get g of 2 is equal to 5 times 2 squared minus 6 times 2 plus 4. Simplify. 2 squared is 4. And negative 6 times 2 is negative 12. 5 times 4 is 20. Minus 12 plus 4. So we get 12. Okay, any questions on this one? All right, so here's one more. So now we're going to take t minus 2, plug it in for all the t's. So we get 5 times t minus 2 squared minus 6 times t minus 2 plus 4. Simplify. So t minus 2 squared can be written as t minus 2 times t minus 2. We're going to multiply. So we get t times t is t squared. T times negative 2, negative 2t, negative 2t, negative 2 times t is negative 2t, and negative 2 times negative 2 is positive 4. And then we can simplify some more. negative 2 is negative 4t. And now we can distribute the 5. So we end up with 5t squared minus 20t plus 20, since we're multiplying 5 to each of these 3 terms. Now we gather all of our like terms. So we have 5t squared. We have negative 20t, negative 6t would give us negative 26t, 20 plus 12, 32 plus 4, 36. And then one more. So here the t, we're just plugging in t everywhere. So g of t is just itself, 5t squared minus 6t plus 4. And then g of 2, if we plug it in, I think we did this one earlier, we get 12. But now the problem wants us to subtract them. So here is my g of t minus my g of 2. And we end up with f times t squared minus 6t minus 8. Now, what if we want to add two functions? So remember, whenever you see f plus g of x, it's always a good idea to rewrite it as f of x plus g of x. So f of x, they tell me is x plus 2. So I'm going to write it here. And g of x, they tell me is x minus 2. So I'm going to write it here. Then we simplify. X plus x is 2x. 2 minus 2 is 0. So my answer is 2x. Subtraction. We have f of x is x plus 2 minus, don't forget the parentheses here, x minus 2. So if we distribute the negative, we get negative x. Negative negative is positive 2. So x minus x is 0, and 2 plus 2 is 4. And then the product here, we get x plus 2 times x minus 2. So we want to multiply x times x is x squared. X times negative 2 is negative 2x. 2 times x is positive 2x. And 2 times negative 2 is negative 4. So the 2x and negative 2x become 0, leaving us with x squared plus negative 4. And then the division, we have f of x is x plus 2 and g of x is x minus 2. There's nothing for us to do here, and so that would be our answer. What is the domain of f of g of x? And so here, notice that you have a fraction, and that fraction has a variable in the denominator. So once you see that it does have a fraction with a variable in the denominator, then there's some restrictions. So in other words, there's some numbers that we cannot use, and those numbers are the ones that will cause us to have a 0 down here. So for some of us, we might be able to see that number right away, and for some problems we cannot. But what you can do is take that denominator, set it equal to 0, and solve for x. So 2 here is not part of the domain. So the domain is all numbers, all real numbers, except for 2. So the way we would write that in interval notation is from negative infinity to 2, union 2 to infinity. Okay, so this is multiplication. So x plus 3 times x squared minus 2, we multiply. So x times x squared is x cubed. X times negative 2 is negative 2x. 3 times x squared is 3x squared. 3 times negative 2 is negative 6. Combine your like terms, and so that would be our answer. So now we can go to compositions. We have, when you see this symbol, it's not multiplication, but instead it's the composition. So whenever you see this, we can rewrite it as f of g of x. So this second function would be on the inside. And so now we can simplify. So we're going to evaluate g of x. So here's g of x. G of x is x minus 9, so we're going to plug it in here. And now we can evaluate f of x of 9. So we're going to take that x minus 9 and plug it in for x. And so we get x minus 9, 4. combine your like terms. So -9 plus 4 is -5. So that's my composition. Well, what if we reverse it? So if we reverse it, now the second function is f. That should be on the inside. So f of x is x plus 4. G of x plus 4, we're going to plug it in for x. And we get x plus 4 minus 9. And we end up with the same thing. But that's a coincidence. That's not always the case. And so now we go to g composed of g. So again, the second function is g. That goes on the inside. So we have g of x minus 9. So wherever you see x in the function g, we're going to plug in x minus 9. Then we have minus 9. So we get x minus 18. Let's try another one. So here we have f composed of g. So g of x is x minus 1. So we're going to take that x minus 1, plug it in for x in the function f. So we end up with x minus 1 squared. Simplify, so we can write it as x minus 1 times x minus 1. So we're going to multiply it, x times x squared, x times -1, negative x, -1 times x, -1 times -1 is positive 1. Simplify, so combine your like terms. Negative x is negative 2x. And if we reverse it, here we get f of x, which is x squared. And now g of x squared means that we're going to go to x here and plug in x squared. So we have x squared minus 1, and we get x squared minus 1. So this shows us here that flipping the order here doesn't always give you the same thing. And then the last one, if we plug in x minus 1 for g, then we end up with x minus 2. So these are composition of functions. And now we're all the way to section 1.9 for inverses. So does this function have an inverse? So well, first of all, if it's going to have an inverse, it's going to have to be a function. Okay, so you always want to see if whatever you're working with is a function. So we use the horizontal line test to determine if it's going to be an inverse. Okay, so this passes the horizontal line test. So that makes it it passes the horizontal line test. So that means that it does have an inverse. So how do we find these inverses? Okay, so first, if we want to determine whether the function has an inverse, then we can do the following. This is going to be a line. And since this is a line, it does pass the vertical line test, and it passes the horizontal line test. So it does have an inverse. But to find the inverse, you're going to replace f of x with y. And so I'm going to rewrite it as y equals 5x plus 4. And so since it has an inverse and it does pass the horizontal line test, then as Mr. Carrizales says, it makes it a one-to-one function. So now that we change f of x to y, we're going to interchange the x and the y. And so we can write it as x equals 5y plus 4. And then we're going to solve for y. So I'm going to subtract 4 on both sides. So we get x minus 4 equals 5y. Divide by 5. And so this is going to be our equation. And to finish it off, we use the symbol for inverse, which is f inverse of x is equal to 1/5 x minus 4/5. And so that's how we would change it to, that's how we would find our inverse. So now, whenever you have two inverses, they're going to reflect on the y-axis. And so
Mr. Gao,
I guess,
why don't
go
we
ahead.
show them? I'm sorry. Why don't we show them
Yeah.
that we can use composites to verify that what you have is the inverse?
Okay, go ahead and
All right.
do that.
Yeah, let me do that. Yes.
Yes, we have time, so that
So
works.
we have time. All right, so we can practice a little bit with composites. Let's verify if in fact we have the inverse function. And before I do that, let me give you an inverse type of situation. If I had the square root of x, right, and if I would square this, which is the opposite of the square root, my value would be x, correct? So what I want to do is similarly, I'm going to use composites to verify that these two are inverses of each other. And if I do this, if I take, grab my pen again, if I do this, if I take the f and I compose it with its inverse, my answer should also be x. Okay, so let's go ahead and try this. Let me go ahead and clear this because I need the space. Get my pen again. and let's go ahead and do the composite of these two. So again, I'm doing this. I'm composing f and supposedly our inverse. And we know it's right because Ms. Chupka always gets it right. So again, my function that I'm going to be evaluating is the f, and to the f, I'm putting in, as Ms. Chuka said, our inverse. And our inverse, I'm going to go ahead and already put it in. It's 1 over 5 x minus 4 over 5. So this value, everywhere I see x in the function f, I'm going to plug it in. So let's go ahead and do that now. So we have 5 times this value, 1 over 5 x minus 4 over 5. Then we have the plus 4. Okay. All right. So let's go ahead and evaluate. I'm going to distribute this 5. So 5 times 1 is 5, and 5 divided by 5 is just 1. It's going to leave me the x. 5 times a negative 4 is a negative 20, and negative 20 divided by 5 is a negative 4. And then we have the outside, the plus 4. Okay. So we combine our like terms. We have a negative 4 plus 4. That's going to give me 0. So when I did the composite of the function with its inverse, I got x. And by me doing this, and since I got an x, I proved that what I have there as an inverse is the inverse of f. Yes? All right. Ms. Chuka, would you like to add anything else?
Yes, just that you also need to do the reverse, right? And that should also give us x. And in both cases, then we know it's an inverse. And that's it. So if you want to download this presentation, there is right above where my mouse is, there's a box with an arrow pointing down. You can click on that and it will help you download this as well. If you want to watch this in a slower time frame and you want to pauses and all that stuff, then our wonderful staff has placed our YouTube channel, and you can always go back and view these recorded sessions. But we thank you and we wish you the best on your exam, whether it's this week or next week. If you have any questions, we do have a couple of minutes that we can stay and help you out. And that was it.
Okay, thank you. Thank you, Mrs. Chuka. Thank you, Mr. Carrizales, for your wonderful presentation. We do want to remind you all about our previously recorded session, like Ms. Chuka said, which are available on our YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TV sessions. So please take the time to fill out the survey. It will help us to give you better service. Before you leave, I want to share the TV sessions that we will have next week. I'll be back with Happy Math Hour next week, where Math 1314 will be covering a standard form of quadratic equations and graphing, and Math 1324, a standard form of quadratic equations and graphing, and Math 1324 will be covering the writing exponential equation into logarithm form. Okay. And I want to remind you that today at 1 p.m. today we'll also have the Student Success Hour, which EPCC, the Mental Health Committee, presents on self-care. Okay. For next week, the Student Success will be covering EPCC Foundation. So thank you all for coming in today. We hope that you all have a lovely weekend. If you have any questions, like Ms. Chuka said, feel free to use the chat box or mic. And we hope to see everyone again for Math Happy Hour next week. Thank you. Have a great weekend.